All right, welcome back. Today we're going to go over Chapter 15 in your text. Chapter 15 is all about filler metals. First of all, we're going to define what filler metals are, electrodes, things like that. There are going to be a few parts of Chapter 15 or Chapter 28, excuse me, that we're not going to use for this unit. Keep in mind this is all GMAW. We're going to touch a little bit on metal core and a little bit on flux core wires, but all the shielded metal arc welding electrodes we're not going to discuss. We'll save that for your shielded metal arc welding class. All right, first, what is an electrode? Well, number one, an electrode, its main function is to carry current. So electrodes, all they do is carry your current. Carry current. You got to remember that, it's very important. Now keep in mind, some of your wires, some of the stuff in your filler metals, they're not going to be electrodes. For GMAW, your wire that is being used to fuse the metals together, that is your electrode. But keep in mind, when you get into your TIG class, your filler metal is not your electrode. Your tungsten would be your electrode. So your filler metal is not always your electrode, but in this case, the electrode is your wire. And its main function is to carry current. We add stuff to the wire to help stabilize the arc, to help increase the carbon content and things like that. So the main purpose of an electrode is to carry current, and your wire in this case is to carry current. Now, the American Weld Society, they developed a numbering system to define these electrodes. So we're going to kind of go through some of these different types of numbering systems that they use. Now, keep in mind, the number one thing, when you actually start making your filler metal and electrode selection, make sure that that wire matches your base metal. For example, we're not going to be using a carbon steel electrode on aluminum, or vice versa. We're not going to be using aluminum on carbon steel. So make sure that filler metal matches the type of metal that you're going to be welding. Now, as we get going into this chapter, I'm going to get a little bit into the carbon content and nickel and what that actually does. So when we start adding carbon into our filler metal, what are your base metal? Basically what that does is that it increases your hardness, it increases your strength of the material, but it decreases your ductility. So ductility is to be able to bend, shape, and form. So sometimes when you actually pick out your filler metal, for example, if you're using a high carbon filler metal, that means you're going to be welding on a high carbon content base metal. So that means that that material is very strong, very hard, and usually when you get into them high carbon content carbon steel, you're going to be doing a preheat and a post-heat. So carbon increases the hardness, increases the strength of material, but it actually decreases, it's called ductility to be able to bend. Nickel basically does the same thing also. So it increases your tensile strength. It also increases the corrosion resistance, and it actually increases the toughness. So when you actually weld in on like cast iron, for example, you use a high nickel rod because it can bend, it's highly corrosion resistant. So hopefully that helped out a little bit. So when you're actually choosing your filler metal, make sure it actually matches your base metal. Now, like I said, AWS, they created a number system to identify these filler metals and electrodes. Your main filler metal for this course is going to be what they call ER70S-6. It could be a 2 here or a 3. What does all this mean? Right at this point, you don't know. So E stands for electrode. R stands for rod. Why would they have rod there? Well, this tells me that this wire can also be used as a TIG filler rod. So when you see that ER, number one, E stands for electrode. That means that that wire is going to be carrying my current. R stands for rod. That means I can actually use it for a TIG rod, filler for TIG rod. So 70 tells me my tensile strength. What is tensile strength? Number one, right? Tensile strength is be able to resist a being pulled apart. For example, if I take these two pieces of metal, these were tensile tested. What they did is they put this in a clamp, and this is being stretched and then pulled apart. So high tensile strength material is going to be higher. So for example, 70 tells me that this is 70 thousandths tensile strength. It's fairly strong. This is probably one of the most common wires that you're going to be using in industry. It's used in short arc, it's used in spray, it's used in pulse spray, things like that. So that 70 is telling me my tensile strength. S is telling me it's a solid. What does that mean? So that wire right here, that circular wire right here, it's a solid composition. There's no flux, there's nothing else added to it, it's just a solid. Now usually it's got a copper appearance to it. They put a very thin layer of copper around that wire to tell you that what that does is it prevents it from rusting. And this here is actually the composition of the wire right here. Usually the 6,203 is determining what type of silicon content that actually has, how fluid that wire is. So for example, in our GMAW class, we're going to be using this wire religiously for all our carbon steels. So keep in mind, E stands for electrode, R stands for rod. That 70 is our tensile strength. Right here's the main one. That S is telling me that it's a solid, and here's the composition of the material. Where is this actually found? If you look at every roll of wire, so here's my roll of wire, here's my center where it goes on the spool, there's always going to be a tag on that roll of wire, and it'll tell you right here, ER 70S-6-2, whatever it means. So when you look at that tag, it's going to tell you what it is. If there is no tag on that wire, I would suggest not using it because you don't know what it actually is. So this will be on that tag of the wire. It's fairly small print. When you get on the lab, when you actually start welding, I'll show you where that's at and where it's located. Now these wire diameters for this rod, they come in many diameters. They might be 035, 045, or what we're going to use out in our lab for short arc and for spray. So keep that in mind. Main thing is, understand what these numbers mean. They're very important. That's how you identify your wire. And once you identify your wire, it's going to basically tell you how you're going to weld with it. If it's for short arc, it's going to tell you what type of gas to use. If it's for spray, it's going to tell you what type of gas to use. So this is carrying our current. That's the main thing. Next thing, there are different types of wire. We talked about the solid. That's used for GMAW. What else is used for GMAW? Well, in this class, we're going to be using what they call ER 4043. Let's get rid of this so you don't get confused. 4043 is a composition of an aluminum electrode. So when you move into your GMAW pulse, when you're welding your aluminum and stuff, this is going to be our filler metal. Same thing. This means electrode. This means rod. And this is our composition of our wire. Now there is, when you look into 4043, it's a very common welding wire or filler metal for TIG. This is what we're going to be using for this course for our wire feed application. We're also going to be using some stainless steel. When you get into your stainless steel wire feed process, we're going to, depending on what we got laying around, some 308, 309, or 316. Same thing. Electrode, rod. Now this is the type of stainless steel wire that we're going to be using, the composition of it. So depending on if you're welding stainless or if you're welding aluminum or carbon steel, this is how you're going to identify your electrode. Now there are some different types of wires we're going to be using throughout the time that you're here at Nicolay. We're not going to be using these wires for our GMAW course, but for example, E71T-1M. Same principle applies. This is my electrode. Now this is a flux core wire. The 7 represents 70 thousandths. The 1 tells me I can weld in all positions. As you can see, flux core wire is a little different. It's not 71 thousandths tensile strength, it's still 70. We'll get more into this when we get into our flux core class. The main thing is this T right here. That T tells me it is tubular. What does that mean? That means that it's tubular. There's a hollow. Now there's outer shield, inner shield. That means that there is flux either in the inside and here on or covering the outside, just like a stick electrode. So T stands for tubular. When you see that T on that electrode or that roll of wire, so you're looking at an E71T, you automatically know that that should be flux core wire. And that would be welding in a flux core welding process. We get over here to the other side. This gets more into what type of gas you're going to be using for flux core. For example, M stands for mixed gas. There might be a C there, or like a 9C. C tells me I run straight CO2 with that gas. These are very common. Typically both of your flux core wires, you can run both straight CO2 or a mixed gas. What I mean by mixed gas, like a 75% argon, 25% CO2. So understanding these wires, it's going to be easier for you to, number one, it tells you what kind of welding process you're going to be doing with that wire, and you can actually identify this wire when your school runs out, you can go grab your own wire, you don't have to aggravate the instructor. So main thing is when you see that T, that means tubular. That's a tubular wire, and that is used for FCAW or flux core. Alright, there is one other type of wire that we're going to use periodically throughout your time here at Nicolay. You notice that there was just an E here, 71T-1M. Notice there was no R. That's because you cannot use that wire for a filler metal for TIG. Same as if we do our metal core wires, it might be E70C-6, whatever it may be, whatever the composition is. That C tells me that is a cord wire. It's a metal core. So when you look at that wire, the center of that is metal core. It kind of explains itself. So when you look at this is a whole different type of welding process. Metal core wire is actually in the flux core family, but it's welded a lot like spray. You use a 90-10 mixture, 90% argon, 10% mixture, and it runs very fluid. It's a very nice wire. So when you actually see that C, that tells you that is a metal core wire. So, kind of do a review. So when you see that S, ER70S, that tells me that wire is a solid. That's what we're going to be using for this course in GMAW, a lot of the solid wires. And you see the E71T, that is tubular, typically used for flux core. our E70C, that's metal core wire. This is the one that we're going to be using primarily. That and ER4043 for aluminum, or the ER308, 309, 316 for aluminum or stainless steel. Main thing is identify the electrode, and the main function of the electrode is to carry the current. We're also using that as a filler metal too in all wire feed processes. So keep that in mind. So when you go out, when you determine what type of welding process you're going to do, identify that wire to that welding process. Make sure that wire matches your base metal. Chapter 28 is fairly short. I hope you got a little bit out of it. It should help you as you're reading throughout the chapter. I also identified the pages I wanted you to look at for this unit in your learning plan. Be sure to read those pages. Like I said, we're not going to get into the shielded metal arc electrodes. We're going to save that for our stick welding class. So that's it for chapter 28 for GMAW. Read through the chapter, take your test, and move forward.